So in this video, we're going to talk about circles. Well, before we talk about circles, let's define what a circle is. A circle is a set of points equal distant from a point called the center. The radius is a segment whose endpoints are at the center and a point on the circle. And the diameter is a segment that passes through the center and whose endpoints are both on the circle. So I've drawn a picture on the side here. The segment in black is an example of a radius. Its endpoints are at the center and on the circle. And the diameters is in blue, and its endpoints are both on the circle, but it also passes through the center. All right, so now I'm going to draw a circle below. Now, I'm going to draw a radius. I'll let the radius be h, comma, k, and the point on the circle, x, comma, y. Now, if I want to figure out what the distance of that radius is, remember, I'm going to use the distance formula. So I'm going to use r is equal to, remember, that's a square root. I'm going to take the x values and subtract them, and then square them, plus I'm going to subtract the y values and square that also. Now, I'm going to square both sides, so it would be r squared is equal to x minus h squared plus y minus k squared. This is the standard form of the equation of a circle. So as I scroll down, all right, so given a circle at h comma k and with radius r, the standard form of the equation of a circle is x minus h squared plus y minus k squared is equal to r squared, where r is greater than 0, because you want the radius to be positive, because it is a distance. Okay, so let's scroll down then, and let's determine the center and radius, and then graph the circle. So it's already in standard form. Okay? Now, the x squared I can rewrite as x minus 0 squared. Now keep in mind now, the center is going to be the opposite value. That's inside. Well, the x coordinate is 0. Now the y coordinate for the center, now that's not going to be negative 3. It's going to be positive 3. And then the radius, well, that's not 9. It is the square root of 9, which is equal to 3. Now, I have that. I can use both of these pieces of information, the center and the radius, to graph this. So I'm going to create a coordinate plane. Label my axes. And label my slashes. So what I might suggest to do is to graph the center of the circle first. I'm going to graph it at 0 and 3. There. Now, all radii are exactly the same. So for me, the easiest way to do this is to go up 3, down 3, left 3, and to the right 3 from the center. So I'm going to go down 3, up 3 from the center, to the right, and to the left. And graph. Now remember, it's a circle, so I like curves for circles. Okay. Now, the center of the circle is really not included. That really should be an open circle. Okay, so I'm going to try to open it up a little bit. Okay. But there's my graph. So if I know what the center and the radius is going to be, I can graph any circle. And standard form of the equation makes it very easy to identify both. All right. Let's take a look at another example then. So again, I want to be able to graph it, and in order for me to graph the circle, I need the center and the radius. Let's start with the center. Now remember, it's going to be the opposite of what I see. So that's 4 and -2. That's the center of the circle. The radius is the square root of 1/4. Square root of 1 is 1. Square root of 4 is 2. Radius is 1/2. So let's graph this then. I'll create another coordinate plane. Label my axes and label the slashes. So now I'm going to graph the center first. So that's at 4 and -2. Now I'm going to draw this as an open circle. Okay. Now the radius is 1/2. So again, from the center of the circle, I'm going to go up 1/2, down 1/2, to the right 1/2, and to the left 1/2 from the center. So here it is, up and to the right, and down and to the left, approximately. So you'll notice that circle is very, very tiny here because your radius is small. All right, so let's scroll down then. Now, note here, x squared plus not y squared is equal to -9 is not a circle since the radius is not greater than 0. If it was x squared plus y squared is equal to 0, then you'd have 1 point. And again, that 1 point would not be a circle. Okay, so now I want to use the given information to write the equation of the circle in standard form. Again, it's nice that you have both the center and the radius. Remember the equation, x minus h squared plus y minus k squared equal to r squared. So you know your center is h comma k. So again, I'm going to write this as x minus 1 squared plus, remember it's y minus a negative. Minus a negative is a positive 2 squared. And remember, it's 6 squared, that's equal to 36. So there is my equation of the circle in standard form. Now, the other example is now I'm given the center and a point that it passes through. Okay. Now, again, I can use the information and the equation of the circle as such. Let's write this out first. Now, I know what h and k are, but now I have a point on the circle. I have x comma y. So I have everything that I need except the radius. But now that I have everything else, plug in. So that's going to be 2 minus a -2 squared plus 6 minus a -3 squared is equal to r squared. Well, 2 minus a -2, that is 4. 4 squared is 16. 6 minus a -3, that is 9. And 9 squared is 81. Now remember, we're writing the equation of the circle in standard form. I really don't care what r is. I do care what r squared is. So in this case, r squared is equal to 97. Now, I now know what r squared is. Let's go back and plug in, putting in just the center and now the radius squared. So it's x minus a negative, that is a plus 2 squared, plus y minus a -3, that's the same thing as plus 3 squared, is equal to 97. And that is the equation of the circle in standard form.